Hi folks, how do we use the mole in calculations in chemistry? This is Dr. K here with today's episode of Science Untangled on the mole road. So to get a first idea about that mole road, we can take a look at a diagram like this, and you can see how it can be used for conversions between gas volumes, masses, moles of course, and particles. If you are starting off with your reactant A, then reactant A, if we start with a gas volume, can be converted into moles using the molar volume. Once you're on the mole road, you can use the mole ratios gotten from a chemical equation, right, to get from moles of A to moles of B. Once you have the moles of B, whether that's another reactant or whether that's one of your products, you can then convert those moles to any of the three that we started off with. So from those moles of B, if we have B here, we can go back to gas volume, of course, but we can also go to mass through multiplying by the molar mass. And we can, although it happens less often generally, we can also multiply by Avogadro's numbers to get to particles of B. By the way, if you appreciate what I'm doing here and you want to know more, then please like and subscribe and leave me some feedback in the comments. Back to the mole road. The mole road is all nice and easy and clean, but there are of course a few assumptions, and you would normally not be asked to do any calculations with those assumptions or about those assumptions, but you may be asked about the fact that there aren't assumptions about it. So let's take a look at a few points. Ideal versus real gases. The assumption is that we're working with ideal gases. That's why we can use molar volumes, okay? On the differences between ideal and real gases, I have done another topic, which you can see on the channel. Now, the molar volume comes with the ideal gas law, no issue there, but the molar volume is not always the same. It depends on where you're starting off from. It can depend on your exam board. Are you using room temperature and pressure, where room temperature is a nice and balmy 25 degrees Celsius, or are you using standard temperature and pressure, where we're starting off from 0 Celsius, in Kelvin of course? And then are your pressures measured in atmosphere or kilopascals? You need to take that into account when you're doing your calculations. And then finally, with kilopascals, there is even the split in whether you're using 101.3 kilopascals, which is exactly 1 atmosphere, or whether you're using the rounded off version where you're using 100 kilopascals. If you're using 101, then you're using 22.4 decimeters cubed for the molar volume. If you're using 100, it's 22.7. And of course, for RTP, it's 24. In the end, it doesn't matter a whole heck of a lot which one you're using, but you need to use the right one for your board, and you need to be consistent with it. The point of all these exercises is to help you understand the ideas, the concepts. We have a few more assumptions here. We assume the water density is just 1 kilogram per decimeter cubed, or 1 gram per milliliter. That's technically only true at 4 degrees Celsius. Different temperatures, slightly different density, therefore slightly different numbers, but the changes are small. And secondly, the density of solutions. Generally, we're working with dilute solutions, or what can be considered dilute solutions. Therefore, the density is just assumed to be the density of water. But of course, when you put something in that water, you're changing the density. We're generally working in a region where you can make those assumptions and it doesn't really affect the result. However, how much difference do you actually think it would make if you did not make any assumptions? I've looked at a few of those points already in my video on ideal versus real gases, but the same thing comes up here, of course. And with that, we are at the end of this video. Please like and subscribe, leave me a comment in the feedback, leave me an answer to that question, and I will see you next time.